In this video, we will be looking at a few examples where decision trees are applied on real data sets. So first off, I want to look at an example that we've actually seen in an earlier video where a decision tree was grown on the iris dataset, which contains three classes, Setosa iris, versicolor iris, virginica iris. And what you try and do is for a new data point, you try and classify which type of iris that data point is. And we talked through this tree and saw how this tree exactly corresponds to the decision boundaries we see on this side. I wanted to highlight a few more things on this tree diagram that we can see here and that we can now understand after knowing how the decision tree was actually grown. So in this node, for example, here we see the decision that this node makes. So it splits the feature space into two regions according to the petal width. So it looks at the petal width of 0.8 and then it splits the input feature space into two regions, one up here and one down here. But we can see a few more things in this diagram. First off, we can see the Gini Index here, and that's actually the score for this entire region. So before we split, what is the Gini Index of all the data points together? We can also see a few more things here. We can see that there's 150 training points assigned to that combined region. Okay, 50 of those points comes from the first class, 50 of the second class, and 50 from the third class. So we've got 50 Setosas, 50 versicolors, and 50 virginicas. Now, after we split, then we've got this blue region here, which corresponds to this leaf node. And then we've got this upper region here, which corresponds to this node here. And what we can see, let's for example look at this region corresponding to this node. We can see that the Gini index for that entire region is 0.5. That entire region contains 100 training points. 50 of them are versicolors and 50 of them are virginicas. This region here, which corresponds to this leaf node, it has a Gini index of 0. Okay, and that makes sense because we've got a perfectly pure region here. All of the training items assigned to that region comes from the Setosa class. So there are 50 items, training items in that region, 50 are Setosa, and then we've got 0 versicolors and 0 virginicas. So you now have a much better understanding of how to read the decision tree diagram from the previous video. Next, I want to look at a practical example on a data set of heart diseases. So this is a data set of people that presented with chest pains, and the data set comes with labels of whether specific patients had underlying heart disease or not. The data set has 13 features ranging from things like the age of a patient to their sex, to cholesterol measurements, and a number of other features. There are 13 features. And this decision tree was grown on this data set. What we can see here is right at the top node here, we've got thal, that's the feature, less than or equal to 1.5. Now, thal is actually refers to a thallium stress test, and the outcome of that test took on one of three values. It was either fixed, it was either normal, or it was reversible. So the thallium stress test is actually a discrete or a categorical input variable, and it takes one of these three values. Now, for constructing the decision tree, the code used to do this just represents fixed with a 0, normal with a 1, and reversible with a 2. So this question here, what that does is it says thallium less than or equal to 1.5. So actually what that does is it separates out the data according to those patients with a reversible outcome of the thallium test with the patients with a fixed or a normal outcome from the thallium test. So all the patients on this side of the tree, all of them, will have fixed or normal thallium tests, where all of the patients on this side have reversible outcomes for their thallium tests. Now, I actually have no idea what it means to have a fixed, a normal, or a reversible outcome, but to a doctor, maybe that would make sense. So this is one of the big benefits of decision trees, is that you can actually present a tree to someone who's not a machine learning expert, but who is a domain expert, and they could then try and make sense of why the decision tree breaks down the input feature space in a specific way. That's one of the big positives of decision trees. Another one is that given a specific prediction, maybe this patient here, they were predicted to, in fact, have an underlying heart disease. The expert can trace through the tree and figure out why that specific assignment was made. So that's another big benefit of decision trees. And then another benefit that this example illustrates is that decision trees can in fact quite naturally deal with categorical or discrete input. From previous videos, you will remember that, for example, in logistic regression, you need to use dummy variables or one-hot encodings to deal with categorical input. But in a decision tree, it can naturally ask a question which says, is this specific feature, is it reversible or not? Is it fixed or not? Is it normal or not? And then it can just include that question in the decision tree. So those are some of the advantages of using decision trees. Decision trees, however, have a couple of weaknesses as well. The one weakness which we've spoken about before is that decision trees tend to overfit on your training data quite easily. So if you just continue to grow the tree with a very, very weak threshold, then each of the training items will basically end up in a separate leaf node, and then that tree won't generalize. The second weakness is simply that decision trees often don't give such good performance as other types of classifiers. So decision tree always needs to put boundaries which are axis aligned, whereas something like logistic regression, we can of course put slanted boundaries in our feature space. But there are also ways to overcome the problems of overfitting and the problem of having axis aligned boundaries, and we will touch on that in some of the follow-up videos. So that concludes our discussion of decision trees. You now know how these models are constructed, how they make predictions, how you can, from their diagrams, figure out why they're trying to make the predictions that they do. And we will see in some follow-up videos that decision trees are actually often used as the basis for way more powerful classification and regression methods.